Okay, so welcome to today's Tech Talk, everyone. We're here with James. He's going to talk about cloud technology and AWS. Let's unmute ourselves and give him a round of applause.
Let's go, James.
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 Thank you. Hello, everybody. Welcome to today's Tech Talk, brought to you by Codesmith and SingleSprout. Today, we'll be talking about cloud technology and AWS. We're going to start off by discussing what is cloud computing, why is it beneficial to us, and then we'll go over some high-level details on AWS. So before we go into cloud computing, let's remind ourselves of what a traditional system architecture looks like. We have our user who logs onto the computer, makes a request to your server. Your server, by the way, is an actual machine that either lives in your office, that you paid for, had to order when you came up with your product, wait weeks for it to come in, and then actually get your environment set up afterwards. Or the alternative was you could rent it from someone who already had one. But again, you're renting the actual entire machine. Your server would make a request to a database, which would then send information back to your server and on to your client, as we all know. Don't forget, if you wanted to load balance, you need to have additional machines paid for. And your database also had to live on a physical machine, also paid for. Let's not also forget that it costs extra money to also have a staff to maintain all this. Seems pretty hectic. It would also often cost a lot of extra time and money, two of our most valuable assets. How much time and money, you ask? Well, a rep from Eli Lilly once said that it used to take them 2 to 3 months to deploy a server. 2 to 3 months. Amazon got that down to 5 minutes for them. And this is a Fortune 500 company with pretty much unlimited resources at their disposal. So think about how this affected startups. Mark Anderson, who's a Facebook board member and co-founder of Netscape, said that back in 2000, their cloud platform used to charge their clients $150,000 a month to run a basic application. That same application on Amazon's cloud platform today would cost about $1,500 a month. That, if you have your calculators out, is a savings of 99%, $135,000 a month, over 1.6 million a year. All that could be going back into the product to improve and make innovations. Or, in other words, we could hire one Codesmith grad a month. So now, what is cloud computing and how does it solve these issues? Well, cloud computing, by definition, is an on-demand delivery of computing resources, meaning servers, databases, and so on, over the internet rather than on an actual machine. You have pay-as-you-go pricing rather than paying upfront to rent a whole machine or buy one. And your maintenance and security is provided by your cloud provider. There are 3 basic types of cloud services. On the left here in all green is what is the traditional server architecture that we are managing the whole thing. And on each service, the blue is what the cloud provider manages. So an infrastructure as a service is the first one, which is the most basic and just provides the computers essentially. The rest is up to us to manage. We have platform as a service, which we'll get into today a lot more because AWS, Google Cloud Platform, and Microsoft Azure is pretty much the type of service that these fall under, where they provide our networking, our computers, our virtual machines as well that spin up the actual servers, which we'll talk about, the operating systems, the runtime, and all we have to provide is the content. Then there's software as a service, which mostly goes to end users. But the reason that Amazon is so dominant today is because they also blend these 2 types of services. In software as a service, all you're really required to provide is data and access. So what are the benefits of cloud computing? Well, first and foremost, of course, is cost. We'll get back into that in a little more detail in the next slides. But let's also talk about global scale. Some of the largest cloud computing companies have database centers all over the world. So no matter where you are or where you're doing business, you can have local data centers that would also provide auto scaling so that you can start off with the lowest amount of resources rather than anticipate the growth of your product and have to pay for all those extra service up front. Basically, they'll take care of making sure that your app scales or that your server scale as needed. Next is productivity, of course, and performance, because now all that is abstracted away from us and we can focus on our product. And there's reliability and security, which are the two main things, peace of mind. So the pay-as-you-go model and the cost of cloud computing is something I like to make an analogy on compared to our utilities at home. The house on the left picture is a traditional cloud infrastructure. Their lights are on in every room, even though nobody's home. They have to have all these extra servers running at all times in case of extra traffic, and they're paying for that 24/7. Whereas in cloud computing, represented by this house on the right, these rooms have virtual meetings going on right now as we speak. The servers are running as needed. This guy up here, I think, is trading some Bitcoin or something. And notice, though, in the other rooms where there's nobody, the lights are off. We have these servers available to us, but they're not in use. Therefore, we're not being billed for them. Similar to how Con Edison wouldn't be billing us if our lights were off, as our parents would always yell at us about. The result is a huge waste of money. And by the way, these aren't solar panels up here. This is a poorly maintained roof because there was too much money going into electricity. If you overpay for your servers, you won't be able to maintain your product as well. Cloud architecture looks kind of similar, but a lot more simple to the naked eye. We have our users who log onto their computers. We have the request that goes out, and everything is pretty much wrapped up in this cloud infrastructure. We have our servers, our file storage, our database, our security, all tied into one product. Those servers can also spin up little virtual machines that actually serve your app. And this also helps the provider because they can rent each server to multiple companies and spin up virtual machines as needed. Side by side, look at the difference. It looks kind of similar at first, but let's remember all these servers on the right cost a bag of money, a lot of money. And we have to pay for each one plus the staff that we have to pay to maintain it. Whereas cloud storage could cost you literal pennies a month if you have a static website. If you take advantage of its full capabilities, you'll pay some money, but nowhere near the amount of money you'll pay maintaining your own mainframe. So let's get into AWS a little bit now and why it's so popular and so huge. Right now, as of Q2 2020, they have 33% market share of all cloud computing in the world. That's a $111 billion industry. They're maintaining about 30% growth every year, which is crazy for a company that size. And the crazy thing is that they've maintained the stronghold on the market over time. Microsoft, the only change in the last few years is that Microsoft Azure overtook Google Cloud, but it's still pretty far behind Amazon in that top spot. The whys of it are that, well, Amazon has more data centers. There's 2 times more regions in their platform with multiple availability zones, meaning you could have just as many regions, but Amazon has more availability zones in those regions. So if one data center goes out, your backup will still have a good chance of being local, or if you configure it that way. This results in lower latency for backup and storage. Amazon also has availability zones that serve 245 countries and territories. Microsoft right now, as second place, serves only 140. And Amazon also has a proven track record as the longest running top cloud provider. They've been around since 2002. Azure launched around 2010 and Google Cloud Platform in 2008. So Amazon has a hefty head start on all of these other services. Amazon offers about 175 different services, many of which I mean, they've just thought of everything. They have just about anything you need to launch an app and maintain an app or do data migration. Like I said, anything you need for platform as a service or software as a service. The main ones that we focus on here at CodeSmith are EC2, S3, RDS, Elastic Beanstalk, Route 53, Identity Access and Access Management. EC2 is the powerhouse. It's the actual server that spins up. It stands for Elastic Cloud Compute. S3 is the storage for your static files, images, videos, and so on. RDS is the database service that they have as a software as a service, which is part of the reason they have a leg up on the rest of the market. Remember, they're one of the few platforms that offer both platform as a service and software as a service at a high quality and high scale. They also offer domain name registration with Route 53 and identity access management for security. Some of the drawbacks and criticisms of AWS, though, is that they're not all that intuitive to use. You have to configure your cloud server. You have to first configure EC2, set all the configurations for load balancing and whatnot. Then click onto a different page, set up your S3, keep track of all the ID numbers to link them together. Same with RDS, and then setting up the identity and access for all your team members on these things. Now, AWS has done a good job of hearing out their developers and what they need. So they've launched, part of their services is bundling some of these services together. Enter Elastic Beanstalk. Elastic Beanstalk kind of wraps all of this and encapsulates this whole process onto a few drop-down labels, so that you can kind of have everything in one place. It's still a little bit of a learning curve, but definitely doable, and still lets you spin up a server in just a few minutes. The way it works, essentially, is that you have your code, which you can upload via GitHub or a zip file. You have services like code build and code commit for CI and CD. They push out your static files and your bundle files out to S3, and then code deploy goes into Elastic Beanstalk, which Elastic Beanstalk spins up your EC2 instance, and also auto scales and takes care and streamlines the whole process of configuring your load balancing settings. It also has CloudWatch, which allows them to monitor the health of your server, as well as give you logs to show you if anything happens along the way. Elastic Beanstalk's setup looks something like this. And like I mentioned, it could be done, it just takes a few minutes. You set up your application name, basic configuration, which is essentially the platform, the OS, which we usually use Linux here, but you also have options for Windows. You have the option of a sample application, which you could change after if you were using code pipeline and code build, or you can upload your code directly via zip file. Here you have options that you can actually configure your load balancing if you're so inclined, or just use their default settings. And then here you'll see a screenshot of what the monitoring looks like once your app is deployed. You'll see here that we have options for different platforms. This one shows Tomcat. We have Node as well, which we use mostly for JavaScript type projects. And a couple of others like PHP and Ruby. Some of the pros and cons of AWS. The pros, they're a very innovative company, still growing, believe it or not, and setting industry records. Last year, they set a record for highest quarter in the industry at 10 billion, and another record of an annual revenue of 40 billion. That's up 30% from the previous year, or just under at 29% from 30 billion to 40 billion, which actually was a step back for them in growth, but was kind of expected because they're such a large company, and it's still pretty exceptional. They have a long track record, as I mentioned earlier, of reliability, and it's customizable to your needs. Even though they take steps to streamline the process, you still have access to configure every little detail of your servers. The other cool thing about Amazon is that there's a free tier available for a whole year for EC2 storage and RDS. Now, as a startup, this could be invaluable, or even as a side project that might take off. You have a year to try this out on a free tier, a luxury that most startups didn't have years ago. The other thing is that they literally have everything, as I showed you earlier. Any possible thing you could need to launch your app or manage your app, it's there, either as a software as a service or a platform as a service. But no tech is perfect. Some of the cons is that it could be difficult to navigate the console and configure. And if you don't configure properly, it could result in unexpected expenses. Think about the analogy earlier with the lights being on in the house. If you don't configure your servers to load balance properly and you have a reduction in traffic and you didn't configure the server to turn off that a specific instance, you might be essentially leaving the light on in a room where nobody's there, or running a server that is not needed. And the other last con I would say about Amazon Web Services is that live support is not available on the free tier. So for smaller companies that might need that free tier to kind of try out the service, they won't have live support from Amazon. Some of the resources can be found on Amazon's website, as well as Microsoft Azure's. And if you have any further questions, you could contact me either at my email, phone number, or on one of my social medias. And thank you all for coming to the Tech Talk today. I will now open the floor for you to deploy your questions.
Well, wait, before any questions, let's give another round of applause.
Let's go, James.
Great job.
Let's go, James. Woohoo! Got his number.
Okay, deploy your questions, deploy away.
Can I ask, James, what are some like examples of services that Amazon has added in like recent years to stay relevant?
So like I said, they've gotten a lot of feedback from developers. I think they do like an annual thing every year to hear feedback from developers, and they've done a good job of hearing them out and staying like one step ahead in the trends. So things like the Elastic Container Services and Elastic Container Registry when Docker came out in Kubernetes, so that they can have a platform to host and manage and maintain containerized applications. Would be one good example, but there's a ton. I mean, Amazon started out in 2002 with just pretty much some data migration tools and expanded to over 175 actual web services. So it's hard to say when exactly everything happened, but that's basically how Amazon stayed relevant and stayed on top of everything.
I have a question, James. I think you had a slide a while back that give like a high level view of the landscape, and you sort of positioned it as like I think it was like infrastructure as a service.
Oh,
yeah, there was and then there was a couple more. You had infrastructure, platform, and I believe it was SaaS.
okay, yeah, this slide here.
Okay, yeah, there we go. That's the one.
Cool.
Yeah, yeah, and then there was you know, the on-premise, and then the infrastructure, like the platform as a service, and then also like SaaS. And I'm wondering, how does like serverless, like the new serverless architectures, how would that like fit in, or does it fit into this landscape?
So I'm actually glad you asked that question. I purposely didn't include it because it's the subject of another tech talk in this series, I believe. But essentially, it is kind of a new kid on the block, and it's under functions as a service. It's a whole other category, and that also includes like Docker Swarm and Kubernetes support. But functions as a service is what that would fall under. Because it basically, you're just providing functions and event listeners that kick off the process that host the code.
Gotcha, thank you. I'm looking forward to that talk as well.
Any other questions?
Well, if there are no other questions, let's give them one more round of applause.
Go, James.
And everyone enjoy your dinners.
Thanks, Chris.
So.
Great work,
Thanks, James. Thanks, Chris.
Great work.